Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed pinacol-type rearrangement, semipinacol rearrangement. When a 1,2-diol or a beta-hydroxycarbinol system is treated with acid, 1 is protonated and leaves as water to form a carbocation, which then undergoes a 1,2 shift, hydride or alkyl-aryl migration to give a carbonyl compound. Moving on to the next step. The starting material is a cyclopentane with C1 bearing an OH group and an exocyclic C6 bearing OH and 2 phenyl groups. This is a beta-hydroxy tertiary alcohol on a cyclopentane ring, a classic substrate for the semipinacol rearrangement. Moving on to the next step. H2SO4 protonates the tertiary benzylic OH at C6, the more stabilized position. Loss of water generates a tertiary carbocation at C6, which is stabilized by the 2 phenyl groups. And for the final step, the C1-C2 bond of the cyclopentane, or the C1-C5 bond, migrates to the adjacent carbocation at C6. This ring expansion converts the 5-membered ring into a 6-membered ring. The C1-C6 bond migrates, expanding the cyclopentane to a cyclohexane ring, placing the positive charge on C1. Loss of proton formation of carbonyl, C1 now bears the positive charge and still has the OH group. The OH at C1 loses a proton to give a ketone, C is equal to O, at C1 in the newly formed cyclohexane ring, with the 2 pH groups remaining on C6. A cyclohexanone ring with the ketone at C1 and 2 phenyl groups at C6, which corresponds to option A. Why other options fail? Option B. Simple dehydration to give an exocyclic alkene, no ring expansion, would not be the major product under these conditions at 99% yield. Moreover, the semipinacol rearrangement is highly favored. Option C. Ketone at C6 with pH at C1 implies an incorrect regiochemistry of migration. Option D. Retention of the starting diol without reaction is inconsistent with H2SO4 treatment. Therefore, the correct answer is A. Therefore, the correct answer is option A.